Okay, welcome back to trigonometry. We are going to be looking at conversions from rectangular coordinates to polar coordinates and polar coordinates to rectangular coordinates. Okay, so it tells you we want to convert -1 or -3 comma 1 to polar coordinates. My advice is draw the point. 1, 2, 3, 1. We're looking at this point right here. Okay, now you might want to memorize the formulas for this, but I'm going to tell you if you draw the picture, you won't ever have to memorize the formula. So what happens here is we have -3, 1. Now, I'm going to go ahead and draw us a little triangle in here. I mean, it's trigonometry after all. We study triangles. And the idea of going to polar coordinates is that we need a hypotenuse and an angle for what this point actually is. So we're going to convert this to an r theta. Usually we use radians, but not always. Okay, I'll say that I will tell you that you're allowed to write this in degrees. Just don't forget to include the degree symbol. Okay, and then you'll be okay. So usually we're going to do this in radians, but as you're learning it, we're going to do it in degrees because it'll make more sense for us. So how can I get a hypotenuse from the two edges of a triangle? Well, wait a minute, that sounds like Pythagoras, doesn't it? So we can say that r is equal to the square root of the x squared value plus the y squared value. So that's going to be that r is equal to the square root of -3 squared plus 1 squared. Now, this is one thing that I noticed that students do mess up when they type in -3 squared. So if I go over here and I type this in and I say -3 squared, okay, they dutifully write down everything they just got. Like, so -3 squared is -9. No. Okay. You know that when you square a number, you get a positive number out of it. So try to remember that you know this. So this is equal to 9 plus 1, and my square root is the square root of 10. Okay, so my r is equal to the square root of 10. Okay, now we have to figure out our angle, right? So again, we have an opposite and an adjacent side. What trigonometric ratio will relate an opposite, the adjacent, and the angle? Well, I think that that's tangent. It is tangent. So we can say that the tangent of this angle is equal to my opposite, which is 1 divided by -3, 1 over -3. Therefore, theta, and we're going to do this in degrees, okay, is equal to the inverse tangent of -1/3. Okay, so hold that thought. We're going to go ahead and calculate it and see what we end up with. So I am in degrees. We're going to say second function tangent. So that's our inverse tangent. And we say -1 divided by 3, right? And what did we get? We got -18.43 degrees, -18.43 degrees. Where is that? Well, -18.43 degrees is down here somewhere. So this is not the point that I graphed, is it? No, the point I graphed is in quadrant 2. This is in quadrant 4. This cannot be the angle I'm looking for. So what we're going to do is we're going to add 180 degrees to it to put it in quadrant 2. So I'm going to go ahead and do this. So we're going to say plus 180, just 180, not 188. So 180, and we end up with we'll end up with 161.5, we'll say 57 degrees. So 151, 161. 161.57 degrees. So my point that I'm looking for is the square root of 10. We can go ahead and it says to 3 decimal places. So we'll go ahead. So we want 5. Let's go ahead and make it 3 decimal places and be proper about it. Okay. So what was it we're going to have here? We're going to say 565. 565 degrees. Okay. Now my radius, my r is going to be, I need the square root of 10. Sorry, not list, just the square root of 10. There we go. And equals, and again, we're doing this to 3 decimal places, 3.162. So we want 3.162, comma, 161.565 degrees. I write the little degree symbol in there so I know it's degrees and not radians. And that is part A for this problem. Okay, so that's the first one. Next one, we want to do -2 7 pi over 6. So let's see, let's write this down. So -2, 7 pi over 6, -2, comma, 7 pi over 6. And we are converting this to rectangular. Again, let's draw it. So when you're graphing polar coordinates, you graph the direction first. So here we're going to say 7 pi over 6 is down here somewhere, right? Because here's 6 pi over 6. We're going to go a little bit more. Now, once we know the direction, we're going to take a walk in this direction, but it's -2. So we have to walk backwards. So we're actually walking 1, 2, and we're going to be up here somewhere. So we're in quadrant 1. Mostly quadrant 1. This is in quadrant 1. So when I'm doing my formulas in here, we're going to go ahead and figure this thing out. So I know that this piece here is pi over 6, and we have a rate of, on R here, hypotenuse of 2. Can you figure out the adjacent and the opposite side of a triangle when you know the hypotenuse and the angle? I think you can. So we're going to go ahead and say the adjacent side, right? That's equal to cosine is equal to adjacent over hypotenuse. So what if I go ahead and I say, let's change adjacent to the x. The hypotenuse is to r is equal to cosine of theta. So my x is equal to r cosine theta. Okay, and I just went back and drew the picture. So we have x equals r was what? R was 2. And my reference angle is cosine of pi over 6. Okay, we're just going to type that in the calculator. Now, I do have to change the thing because we go to mode, and then instead of pi over 6, we're going to change that to radians so that we get the right thing here. Okay, just change it to radians. We're going to say 2 times cosine of, where's my pi? There it is, pi divided by 6. Okay, and I know it's going to be square root of 3 over 2, so it's going to be 0.66 or 0.866 rather. So 2 times 0.8, I should get like 1.6-ish or something like that. Okay, 1.72. That's pretty good. So we can say this is 1.732. 1.732. Let's do this. Let's do the y value. So we can say what relates the opposite, the hypotenuse, and the angle. That's the sine. So we can then say that we have the y over r equals sine theta. So y is equal to r sine theta. Y equals 2 times sine of pi over 6. I know for sine of pi over 6, it's going to be a half. So this is going to be a real easy problem. We're going to get 1. So let's go ahead and type this in. So we're going to say that y equals 2 times sine of, where's my pi? Pi over 6. Enter equals, hey, look at that, I got 1. So the point that I'm going to be reporting here is going to be 1.732. That does look like a point in the first quadrant. They're both positive. So I'm pretty happy with how this turned out. Okay. So that would be my part B here. Okay. Part C, let's go all the way back up here. We could say, nope, not all the way up there. We could say we have -3, 3 to rectangular, or to, yeah, -3, 3. And we want to convert this to rectangular. Be very careful with these because this 3 here, is an angle. It's in radians. Well, what the heck is that? Well, pi radians is almost, that's a little bit more than 3, right? Pi is 3.14. 3 would be almost pi radians. So as I'm going through to graph this thing, my angle is going to be 3. It's going to be over here somewhere. That's 3. And again, we have to take 3 steps backwards in this direction. So we're actually going to be down here somewhere. So 1, 2, 3. I need something in quadrant 4. Okay. So again, we have a hypotenuse and we have an angle. And I'm going to go ahead and see what that's going to tell me. Now, the calculator knows where 3 is as far as rating goes. It knows it's in quadrant 2. It's going to apply the correct sign, SIGN sign, in order to make it so that we're getting the right thing here. Okay. So we could say this is going to be -3. We have, yeah. So we want x equals -3 cosine of 3, and we'll see what that lands us. Y equals -3 sine of 3. Just make sure you're in radians, and this will work out just fine. So I'll double check it. We are in radians, and everything should be good here. So we're going to say we have -3 times, not divides, but times cosine of 3. All right. Hey, would you look at that? We got 2.9. Yeah, it's pi, so it's almost going to be -1. So we end up with we'll say 2.97 in this case. So we had 2.97. That's my X value. Let's go ahead and make sure we put that on our X. That was 2.97. Okay. Sine is going to be almost zero. So we have negative 3 times sine of 3. And again, it knows it's in the second quadrant. So we end up with negative 0.423. So negative 0.423. So the point I'm looking to say is 2.97, comma, negative 0.423. As I'm trying to graph this, 1, 2, 3-ish, and then down by a little bit, and I get something in the fourth quadrant. I'm pretty happy with how that ended up. Okay, so that's how you do a conversion problem. Okay, thank you very much for watching the video, and I will see you in the next one. Take care.